Back to class 3. We're going to do another example, relative motion example, and this one has like real world applications here. So this is problem 11-129 from Johnston, like the 8th edition. I think that was the problem number. So the instruments on an airplane indicate that with respect to the air, I'm going to call it wind, the plane is headed 30 degrees north of east with an airspeed of 480 kilometers per hour. At the same time, the ship B indicates, the radar on the ship indicates that the relative velocity of the plane with respect to the ship is 416 kilometers per hour with a direction of 33 degrees north of east. And we know that the ship is going south, right, perfectly south at 20 kilometers per hour. And we want to determine the velocity of the wind, the velocity of the airplane, and the velocity of the wind, right? So this might not always be the scenario of things that are known and unknown, but it is a more complicated problem that will kind of mess with you a little bit. So let's try to work through it together here. All right, so in my approach to this, I might try to organize my thoughts and try to see what it is that I know. First off, I'm going to say wind, right? So I'm going to say that the wind is going to have a velocity of v subscript w, and the airplane is A and the ship is B, right? So there's three things that have velocities, and there's some of them are velocities and there's also velocities with respect to each other. So I'm going to start with the ship because I know that in the real world, right? What we want to find is the velocity of the airplane with respect to the world and the wind with respect to the world, as opposed to these other guys right there, right? So we know that the velocity of the airplane with respect to the wind is going to be 480, and we're not going to bother with changing the units out because everything's going to be in kilometers per hour, so we don't have to convert anything. And it's so in the x direction, right, it's going to be 480 times the cosine of 30, right, and it's heading that's going to be I plus 480 times the sine of 30 j. It's just a good place to start, right? So doing out the math, I get 415.7 I plus 240 j, and kilometers per hour if we want to be concise on that. And let's see, what else have we know? We know that the velocity of the plane with respect to the ship, so that's going to be A with respect to B, right? Because it's the plane is A and this B. So the velocity of A with respect to B is going to be 416, and it's still going north of east, right? So it's still going up and to the right. So we have 416 cosine of 33 I 416 sine 33 j, and 348.9 I plus 226.6 j kilometers per hour. Something we also know is the velocity of B is going to be negative 20 j kilometers per hour. All right, so we set up and got some stuff. We got some in-between steps, but now we got to kind of think our way through. And I think triangles are going to be the best way to go about that. And we can monkey around with this first guy right here, but I think this is the one that's going to help us the most because we have A with respect to B and we have B. That's going to allow us to find A, right? You see that logic? And now, so we got to set it up the right way to be able to do that. We know that the velocity, so we could find the velocity of A if we know the velocity of B and we add the velocity of A with respect to B, right? We could also do that in terms of triangles right here, because we have B as the reference, which is going to go straight down, and we're going to add to it A with respect to B. So we're going to go nose to tail, so it's going to be like this. So we can expect, I think, so this is B, this is A with respect to B. We can expect this thing to go up like that, right? Yep. So this is V of B. This is V of A with respect to B. And if we were going to take a look at these angles right here, that right there would be that would be our 33 degrees right in there. All right. So we could continue using the vector triangle geometry right there, but I'm just trying to like get it straight in my mind what's actually taking place, which is kind of the important part. So if you want the velocity of the airplane, take the velocity of this, which is 20, negative 20, and add it to this right here, this A with respect to B. So let's write that out. That means that this right here is simply going to be 348.9. I don't know why I put brackets in there, but that's I plus, and so we're going to add negative 20 plus my 226.6. We could actually do that in our heads, right? J kilometers per hour. And so we get the velocity of A is 348.9 I plus our 206.6 J. Let's get the magnitude of that. 348.9 squared plus 206.6 squared, and we end up with 405.5 kilometers per hour. And the angle, I'll say it's the angle of A, is the inverse tangent of rise over run, 206.6 divided by 348.9, and we get 30.63 degrees, right? So the answer to that would be part A, right? Because we wanted to find the velocity of the airplane. This is the velocity of the airplane. V of A is equal to 405.5 kilometers per hour at an angle, and it's that way with respect to horizontal, right, in the upper right hand quadrant of 30.63 degrees. Now if we want to have we want to have part B, which is the wind speed and the wind speed and direction. All right, so that'll be a vector as well. So now we know the velocity of the airplane. Now we can find the velocity of the airplane with respect to the wind, right? So now they're going to be pretty tight, right? Because this is 30.63, and this is 30 degrees, right? So it's pretty. It's going to be a pretty narrow triangle, so we might actually need to exaggerate it a little bit, right, to be able to do there. But we do know the velocity of the wind is going to be equal to the velocity of the airplane plus the velocity of the wind with respect to the airplane, right? Which is also, okay, but that's not what we're given. We were given the velocity of the airplane with respect to the wind, so we might want to instead say velocity of airplane minus the velocity of the airplane with respect to the wind, right? We have the airplane with respect to the wind. Now we can instead get the, we had the, yes, this is what we have, right? So we know that these two are opposite from each other, right? So we could take, maybe I'll confirm it with the triangles instead of trying to calculate it out. All right. So anyway, instead of trying to use it that direction, so if the airplane is going to be 348.9, we're going to subtract out 415.7. That's going to be an I. Plus, then we'll take this 206.6 and subtract 240. J. And what we're left with is going to be, I believe, it's interesting. How did that happen? Oh, I see. Okay. Okay, it had negative 66.80 I plus negative 33.43 J kilometers per hour. And so that's the answer, but we want direction. We want magnitude and direction because we want speed. So we go the velocity of the wind is going to be equal to square root of 66.80 squared plus 33.43 squared. And that's going to equal, I didn't get out the number. I dropped the sig fig here. I'm at 3 sig figs for the answer. And the direction there. And these are both negative and negative, so this is the lower left-hand quadrant. So I won't bother with any negative signs in here. And so that just goes 33.43 divided by 66.80. And that ends up being 26.6 degrees. So the answer to this is the velocity of the wind, and is 74.7 kilometers per hour at, sometimes I'll draw I'll write the angle first and then do the quadrant. I guess I'll do it at 26.6 degrees, lower left-hand corner right there. You can see that that's a pretty small value compared to our 400 and what did we say? 405 is what the airplane is doing, and the perceived one of the airplane was 480, right? So it's going to be a pretty small looking triangle right here. The way that I would write out this right in here is the airplane, which is going up this amount right here, plus this wind, which is going to be like something like that right there, right? So this is V airplane, yeah, and we're going to add in V of the wind. Oh, I did that wrong. Yeah, let me see. I'm trying to think my way through as I'm writing on this. I'm sorry. Oh, wait, that went off the edge of the thing. Oops. For velocity of the wind plus I have it written the other way around, right? So I might actually want to write out the velocity of A is equal to the velocity of the wind plus the velocity of the airplane with respect to the wind, right? This is actually what I'm given, right? So this is what I just found, and this is what I had been given, and I found this one from there. So I don't know if it really matters, but the velocity of the wind is coming up this way. Let's say the velocity of the airplane with respect to the wind, right? So we're going to add this one to this one, so that comes down not that much different of an angle. We'll do it on AutoCAD here in a second to confirm this. And then that's going to be, this right here should be the velocity of the airplane. All right, so let's try this out in AutoCAD. Let's first confirm the first part, right? So I'm going to start out at the origin here, and let me turn off my orthog. No, I'll leave the orthogonal right there. Yeah, I don't know if I'm going to use a scale. Yeah, let's just see what. I'll just use full scale. Let's see what happens. I'll have to zoom out a lot. So this magnitude first, or the first thing that we found was the velocity of B, right? Well, we got. We could. Okay, sorry. Let me organize my thoughts a little bit better. We had the velocity of A with respect to B. That would be the 416. So let's use this one, 416. 416. Boom. I think I have to zoom out a lot for this. Let me get zoom extents. Where'd you go? I hate it when I can't find things. It's been about 9 months since I used AutoCAD. There you go. There you go. Okay, I got it. All right, so I could just drag this thing over there. Not great usages of the, not great display of my drafting acumen. So this was here. That was the 416 I just did, and we went 33 there. Okay, so there you go. And then that was the 416, and then we also knew that the thing was going due south, right? Yeah. Oh, due south. And the speed of it was, what, 20? It's not a lot, right? Pretty small there, right? So here you go. This is how we, boom. All right, so that was this first one was the airplane with respect to the wind. So let's go ahead and just, whoops, come on, stop. I think the text is going to be too small here to read. Yeah. We zoom in on there, 416, right? And am I too lazy to fix this? Let's see, what is the time? Let me pause. I'll fix the size. Let's see. I gotta make sure I zoom in. I don't accidentally hit the leader. There's 20, and now you can find that we have here to there. Here's our 405, right? 405.45. Yep. And if I draw this guy right in there, and you can see what the angle is going to be. There's your 31, but let's change the dimension style and just modify this and then go for angles, primary units, degrees. There you go. Give a couple decimal places onto degrees. Yep, 30.629. Yep, so we got 30.63. Yep, that confirms it. Now that's that first triangle with the airplane and the boat, right? The airplane and the ship. Ship is going this speed. Airplane is actually going this speed, and this was the relative speed to it. So if we take this same line here over, and now I guess I'm just going to pick some spot. Let me just pick some spot. Okay. Now one of the other vector that we know, it was the air with respect to the wind, right? So we had 480 So we can, I'll just drag him. Could extend him. I didn't. Let me get rid of these guys. And then this is, we were told the direction of that is 30 degrees. 30 degrees. Okay. So, our triangle we're going to move this guy, so he's going to go over to here. So you can see how small that's going to be. And so this right here is going to be the wind. Boom. You could barely make that out. You could barely see how that's a triangle. But here you go. That's the length right there of your 74.7. And let me see. I guess I'll make it just to there. And then we go to this angle right in here, right to there. You can see that we have our 26.6 is what we got, right? So it won't let me move this. We're in a nice place. Something like that. Yeah, not a very good drafting thing. We won't leave it like that. But anyway, that just confirms with the vectors that what we had before, right? And if you want to look at these more closely, that goes to there. Here's our 480, and right here, there's a lot of stuff going on right down there, really close in. Yeah, gotta be careful. Get it onto the end. I could hit a snap instead, but I didn't. Oh. Well, I must have hit. Oh, I must have hit the wrong one. Go to the snaps. Snap. Snap. There you go. So there's the solution by way of vector triangles graphically on AutoCAD. Not something I'm asking you to do, but I'm just showing you that when I'm working on a problem and I'm not certain of the answer, I would use other tools at my that are available to me just to double check on the thing. So we are done.